today about some recent projects we've been doing focused on arterial stiffening and cognition. So Dr. Brewer already showed a similar kind of figure to this, but it's showing the timing of different Alzheimer's disease biomarkers. So we can see here these biomarkers going from normal to abnormal as a function of clinical disease stage. So we have normal cognition to mild cognitive impairment to clinical dementia. And there is some kind of discussion and debate in the field about the exact timing and exact ordering of these different biomarkers, but in general it's thought that amyloid changes early on, this is here in red, as Dr. Feldman and Brewer talked about, and then tau, here in blue, then changes in brain structure, memory, and then finally clinical function. So what's important to note, and I think isn't always fully considered, is when there are Alzheimer's disease changes in the brain, so the tau and amyloid that we've been talking about, there are often co-occurring other types of changes, and vascular brain changes in particular are very common. And this can be, different types of changes, but often we think about strokes, so larger strokes or even small strokes, small bleeds or hardening of the arteries, and other types of related changes. So these graphs here that I'm showing, this is actually work from Rush University in Chicago, but they have a large cohort there. And during life, they diagnose people with either normal cognition, mild cognitive impairment, or Alzheimer's disease. And then an autopsy, look at the underlying types of changes they're seeing in the brain. And there are participants who have normal cognition. So the primary or most common form of pathology here was vascular disease, so vascular changes. And then in people with mild cognitive impairment, it was very common to have both Alzheimer's disease and other forms, so vascular and other types of changes. So here that these are in these kind of dark blue are different mixed pathologies. And it was only about 8% that had pure Alzheimer's disease. So that's this little kind of light blue wedge. And even in people who are diagnosed during life as having probable Alzheimer's disease, again, these mixed pathologies, Alzheimer's disease, vascular disease, and other pathologies co-occurring together was very common. So that's all these wedges here. And then the pure Alzheimer's disease was only about 3%. So this small slice.
What's the dark blue wedge, because we can't read it?
Yeah, so it's probably hard to see. So it's Alzheimer's disease plus vascular plus other changes. So like 3 different changes at least, yeah. So within our lab, we've been really focused on vascular contributions to cognitive decline in aging and in Alzheimer's disease, in part because vascular factors are very common, so things like high blood pressure or hypertension, high blood sugar, diabetes are very common in the population. And they're relatively understudied within the field of Alzheimer's disease, although there's been more attention to them recently. And they're potentially modifiable. Dr. Feldman presented some really exciting work on recent developments in amyloid treatments, but a lot of vascular factors also can be modified either through lifestyle interventions, things like diet, exercise, and different medications like blood pressure lowering medications. So one marker that our lab has been really interested in, and we've been studying with the ADRC, is arterial stiffness. So this is the reduced ability of the arteries to expand and contract in response to pressure changes. Arterial stiffness does increase just with normal aging. There's less collagen and elastin in the vessels. And also conditions such as high blood pressure, diabetes can exacerbate these age-related changes. And with arterial stiffening, we can have damage to the vessels, reductions in blood flow, and there also can be interference with amyloid clearance. So there's pathways along the vessels that allow drainage that might be impaired. So we think arterial stiffening could be an important potential target of interventions, or also just an important factor to consider in trials of dementia, because people who have a lot of arterial stiffening or vascular disease may respond differently to treatments. And there's different ways that we can measure arterial stiffness. So one way we've been using within our lab is called pulse pressure. This is kind of a surrogate or indirect measure, and it's calculated as a difference between the upper and lower numbers of your blood pressure. And elevated pulse pressure can mean that the arteries are less flexible, the heart is working harder, or potentially both. And in our work, we've shown that elevated pulse pressure has been linked to cognitive decline and Alzheimer's disease biomarkers and other factors, but I'm just going to present a couple of different examples of studies we've done here. So in this study, we looked at time to progression to a dementia diagnosis. So here we had people who have high pulse pressure in orange, so more arterial stiffening, and in black, people with low pulse pressure, so less arterial stiffening. And you can see this orange line. These people are becoming demented or being diagnosed earlier. We've also looked at pulse pressure in relation to tau accumulation within the brain using PET imaging. So in this study, we looked in different regions of the brain. So these are 3 different regions that are all involved early on in Alzheimer's disease. And we looked at pulse pressure at baseline and then tau change over 12 months. So you can see there's this increasing, so higher pulse pressure and more tau accumulation. And in this study, we did also control for adjust for a lot of important risk factors, including genetic risk for Alzheimer's disease, so ApoE4 status, and we still saw these effects. So now, at the ADRC, we've been collecting pulse wave velocity data, and this is a more direct measure of arterial stiffening compared to pulse pressure. So pulse wave velocity is the velocity at which pressure waves, which are generated by the systolic contraction of the heart, propagate along the arteries. And it gives us information about how elastic the arteries are. And a higher pulse wave velocity indicates stiffer arteries. And people may have seen this machine here. So that's the sigma core that we use to collect the pulse wave velocity data. And in the past, much of our work again is focused on pulse pressure, so it's kind of indirect or surrogate marker. And now, with this machine, we're able to get the more direct measure of pulse wave velocity. But it still remains unclear how arterial stiffening may interact with Alzheimer's disease risk factors to affect cognition. So that's something we wanted to study. We want to see if there were synergistic or kind of combined effects of elevated pulse pressure, arterial stiffening, and different Alzheimer's disease risk factors. And in this study, we focused on genetic risk, so ApoE4 status, and cerebrospinal fluid Alzheimer's disease biomarker positivity, so looking at the ratio of tau and amyloid. So this is a study that we published recently. This is a little bit about the ADRC participants that were involved in this particular project. So you can see there are almost 200 people, and most were cognitively normal. So we have a few MCI that were included, but most are cognitively normal, and kind of in the mid-70s was the average age, and overall, a relatively healthy and well-educated sample. So we wanted to look at how pulse wave velocity related to different cognitive abilities. So we looked at several different cognitive domains. So we have memory, executive functioning, so things like problem solving, thinking flexibly, reasoning, language, visual spatial skills, and attention. And what we found was, across our whole sample, that higher pulse wave velocity related to worse executive function. So this line here. Then we also wanted to look at pulse wave velocity kind of in relation to the different Alzheimer's disease risk factors. So again, genetic risk and looking at ApoE4 carriers. And we looked at the same cognitive domains here. And then up here in this top part we have in red these are ApoE4 carriers and blue are non-carriers. And what we found was it was really in memory where we saw effects. So people who had high pulse pressure or high pulse wave velocity and were E4 carriers had worse executive functioning. And that was similar when we looked at Alzheimer's disease biomarkers. So here, again, this in red are the biomarker positive people and blue are the negative. And you can see this line here, so higher pulse wave velocity and poorer memory performance. So we were excited about this data because it seems pulse wave velocity, it's a relatively simple, non-invasive way that we can assess arterial stiffening, and it may be a useful marker of risk for cognitive decline. What we want to do now is look longitudinally, because this data I showed you is just cross-sectional, so one time point. But we want to see over time, is pulse wave velocity predicting cognitive decline? And that's something we're working on right now. We're working on those analyses. And ultimately, we're interested in vascular risk factors because with treatments, this might have an important impact on preventing cognitive decline and dementia ultimately, which is what we all are here to do and want to do. So this is my lab. I want to thank all my lab members, and also again thank the ADRC and all the participants and families for all you do for our research. Thank you.